All right, so looking at this review, number 1 through 3, these should be some pretty easy problems as covered on 6-1. On the quiz that you're going to see, I don't believe there's any questions that deal with the form. So these right here, I'm not going to spend a whole lot of time going over those. Main one I'm focused on are the bottom two. So if we look at number 1, number 1 is actually kind of a tricky one. When we look at the form on really all of these are going to be linear. Well, like I said, we're not going to really worry too much about that one. Direction is going to be very important. So if you remember the direction, it's either positive, negative. If it's neither, it's going to be going either horizontal or vertical. So we do that based on the slope. And if we look at number 1, we see the direction of it's like this. That is a negative slope right there. And then the last one, you also see a question that's going to ask you about the strength or the association. So like I said, this first one's a little tricky. You could go either way if it's strong or weak. It's honestly right in the center, and on your quiz, you're not going to have one that's so, in the middle area. Personally, I would say that this one is strong, but if you said it was weak, I mean, that's fine. But like I said, on the ones on your quiz, it's going to be like black and white. You're going to be able to tell if it's strong or weak. So with that in mind, let's move on to number 2. Number 2, we're looking at the direction. The direction on this one, even though our dots here are scattered, it's still going in that direction. So that's going to make that one positive. As for the strength, it's pretty easy to see that this is going to be a weak strength there, or weak association, as our dots are scattered. And lastly, we're going to look at number 3. So like the one before, we're going in this direction. So that's going to make it positive. And then as for the association on this one, it's going to be strong. So problems like 2 and 3 are the ones that you're going to see. Moreover, it's going to be kind of black and white, plain as day, which one it's going to be. One like number 1's tricky, but you won't have one quite like that. So that's how you do these first 3. All right, so number 4 asks, what are the 3 things we need to consider when analyzing a display of statistics? Those are the ones that we just did. So the form, strength, and the direction. So I'm not going to spend a whole lot of time talking about those. Obviously, they're kind of self-explanatory. At this point, the form is really telling you if it's linear or nonlinear, strength if it's strong or weak, and then direction, positive or negative. So we're going to go ahead and move on into our next one. So this next problem should look pretty familiar, as we had actually a problem exactly like this on your review sheet, but kind of skim through this one. So it says that we have John. He has a new job. He gets $45 for being a salesman, and then he makes $25 each time that he makes a sale. So before he sells anything, he makes his $45. So if he makes a sale, he's going to get $25 from it. So we're going to have 25. So this is going to be one item that he sells. So with that one item, he gets $25 with it. So we're going to multiply those together, then add on that 45 that he already has. So plug that into your calculator. You're going to get 70. When we go and do when he sells 2 of them, just going to place that right there. Again, plug into your calculator, we're going to get 95. And then again, going to replace that 2 with a 3 this time because he sold 3 items. Plug that into your calculator, and we're going to get 120. So that part's pretty easy. Problems down here is really what, are more important we need to focus on. So first one's asking the recursive rule. So we need to figure out where he starts out at. Well, before he even makes a sale, he is already going to make $45 right here. So that's our starting point. So I'm going to say m of 0 equals 45. As for the rest of the function, we're going to set up with our notation of mn plus 1 equals mn. And then each time what's getting added on is the 25. So for every cell, he gets $25 added on. Pretty easy there. All right, so number 6, it's asking about the explicit. So all we have to do is really just look at the process on this one. So for the explicit, y equals 25x plus 45. And that's really just taking this process and moving it over to the explicit, replacing the 1, 2, and 3 with your x. So if you remember, here's your x right here, here's your y right here. So just plugging it in like that, easiest way to solve that one. So I'm going to change it up, go a different color, so we got some room. So number 7 right here, so I'm going to work out number 7 here so we have some room. wants to know how much money he has after he sells 42 items. So first thing we need to identify is if the number they give us, if it's an X or a Y. In this case, we're talking about items, so that is going to be your X. So we're going to take the explicit here. We don't know what Y is. We have 25. We're going to plug this 42 in plus 45. So again, this is just calculator work, plugging everything in, and the answer that you should get is $1,095. All right, and then I'm going to switch the color one more time. Let's go with a green right here to do number 8. So number 8 this time, we're going to be working backwards. Tells us that he needs to make $3,500. So if we look, here's your money over here. So we have our $3,500. It's going to equal, actually I'm going to make this a darker green so we can see it. So we got 3,500 equals, and then we have 25x plus 45. So in this little equation here, we're solving for your x. So simple algebra, just plug in, solve. So we're going to have to subtract the 45 over, divide by 25. We're going to get 138.2. Obviously, he can't make 0.2 of a sale, so we got to round up. So here's your final answer. He needs to sell 139 to make his quota of 3,500 to keep his job. All right, so top of the back page. This time we're just writing a function. So when it means function, it means explicit, and then our recursive rule for each of our scenarios. So number 9 tells us that Jack is an electrician. He charges $85 per house, or for a house, and then $40 per hour. So this is a lot like some of the first problems that we worked. Pretty basic and easy, honestly, in Algebra 1 type problems. So I'm just going to write over these so we know that this is the explicit. So for the explicit rule, in this case, we're going to have y equals, it's $40 per hour, so it's going to be 40 times our x, and then plus that initial fee of $85 for the house. Recursive rule, remember there's 2 things that we need. So I'm going to call this M of O, and it's going to be where we start out at, which is 85. So from there we're going to have our function that, or this little notation that we always have with our recursive rule, and then plus our 40 that gets charged for every hour. So that's how we work one of those basic ones that we saw. This is honestly like in 6.2, 6.3, we saw stuff like this. Now, number 10 and number 11, a little more difficult. So it says that Jill has $500 in her savings and she acquires 12% interest each year. So before we completely jump into this problem, we need to think back to, honestly, 6.8, the problem that we did, or the section we did yesterday. And then this kind of ties in also with 6.4, if you remember that one with the ball bouncing up and down. But anyway, with when we deal with exponential, it's either going to be decay or growth. In this case, we're talking about interest in money. That's going to be growth. So this 12% as a decimal is 0.21. We need to add the whole number 1 to it, so we can represent that her money is going to be growing. So it's going to be 1.12 here. So the explicit rule, we're going to have y equals, we're going to have the money up front that she has, that 500, times the 1.12, with our x being up there. So the x is being squared. Let me erase some stuff right here so we can look at that a little bit better. So our x is going to be right there. So y equals 500 parentheses 1.12 to the x power. Recursive rule, well, she starts out with 500, and then the next part of our recursive rule is always going to be this. And then instead of adding, we're going to multiply by her growth rate of 1.12 there. So that's how we go and solve a problem like number 10. And then the last problem in this little set right here, number 11, it says that Bob opened an IRA and then with $1,500 and he gains 5% each year, that he contributes an additional $1,200 onto it. Now this one is a lot like the one that we saw in 6-8, specifically number 3, where we have this additional $1,200 that's being added onto it each time. So that's actually going to affect our problem a lot. So our function rule, that's going to be the explicit, but if you remember, we can't make an explicit rule out of this because we add on this constant of 1,200. That's going to constantly change this little number out front in all of these. So that's going to mess a lot of the stuff up that we do. So in this case, there is not an explicit rule. So if we look at our recursion, that's the only one that's going to work for this situation because of this 1,200 that gets added on each time. So it says that he starts out right here with this 1,500. So m of 0 equals 1,500. When we go and do the next part, it's the same setup of n plus 1 equals mn. Now with this 1,500, we're going to get this 5% added on. Like the problem before, this is going to be growth. So we're going to take this 5%. That's going to be, keep running into this area right here, needing a different color. So let's actually go with white and see how that looks. So that's 0.05. We need to add 1 to it. So we're going to get 1.05 right here. So it's going to be multiplied by our growth rate right here, and then we're going to add on this 1,200. So that's going to be our final recursion rule right here. So we have to be careful with this one, make sure that we recognize that we're not going to have an explicit, we're only going to have our recursion, and that we make sure we add this 1,200 there. So I'm going to stop this video right here. This is going to be part 1, and then the rest of the worksheet is going to take a little bit more work than these first few problems, so that's going to be in the second part of this video, or of this worksheet.